let's move to the second industry paper, a hybrid multi-agent conversational recommender system with LLM and search engine in e-commerce. And this is a paper from jd.com.
Hello, ladies and gentlemen. I'm Jianwei, and here to present this paper on behalf of Guangtao from Jinghe Company. And sorry, it looks like a technical problem. Okay, sorry again. And I'll introduce this paper from three aspects like background, system design, and results. As an industrial LLM application, there are several factors to be considered. First is scalability, since the real recommended system is really large, and the resource consumption per user request. And here we will use a LIPR, that is LLM inference per request, for the resources we need in online serving of a multi-agent system. And intuitively, less LIPR means less resource and higher scalability. And the second is latency. As the streaming text application, first token latency is defined as the duration between user input and first token response of a system. And third is user satisfaction. That is really important, right? Which denotes how often the options of recommended items are chosen by users. And last is business goal, since we are an e-commerce company and we will take GMV into consideration. And this is a multi-agent conversational recommendation system. And the MACRS integrates three responder agents, that is asking responder, recommending responder, and chit-chat recommender, and one planner agent. This agent employs models like GPT and Llama with tailored profiling and action modules to meet the objectives in user preference elicitation, recommendation delivery, causal conversation, and planning actions. And this multi-LIPR approach can be financially burdensome for widespread industrial use due to its high cost and limited scalability. Some other RAG works suffer from the high first token latency problem, which challenges the user's patience. And our work exclusively concentrates on developing an industrial scale conversational recommender system that CRS characterized by minimize the first token latency. The central agent is crafted to handle all user interactions, eliciting user preference and offering user options, generating search queries. And however, due to the large language model sometimes producing inaccurate output, and that is hallucination, as mentioned before, in the ever-changing nature of supply chains, the search queries generated by the central agent might not always yield results from Jinghe's search engine. To address this, we have implemented a relative search model capable of providing adjustments or alternative queries from the central agent search queries. In our baseline CRS, processing each user input involves three sequential steps. And the first is an LLM agent creating an intent of a search query. This query being processed by a search engine for matches and using these results to inform subsequent responses. Sorry, I'm sorry again.
Sorry, the pointer is not working, so the speaker was not able to go to the next slide.
I don't know how to get a slide. Oh, I mean, there are comments.
No, you cannot do this.
I cannot do it. Okay. Sorry again. And this is a working flow demo of our system and its Hybrid-MACRS. Each user session begins by loading the user profile, which informs the initial prompt and share the chat SR generation style. And the chat SR promptly reacts to all user inputs and it adapts its output accordingly. If a user's dialogue falls to a broad range of interests, chat SR will respond with the preference elicitation and user option generation. If a user's shopping interest is clear, ChatSR will reply with search queries and recommendation. Otherwise, ChatSR will reply with search queries. Otherwise, ChatSR will do chit-chatting. When producing such queries or options, they are marked with special tokens. Thus, the central agent performs a basic rule-based check for those tokens to identify search requests or user options. Identified search queries trigger the search agent to provide ranking items and alternative queries with their ranks. In scenarios where LLM misjudgments occur, resulting in irrelevant queries or when items are unavailable, the system adjusts by substituting or modifying queries with alternatives in their rank list. For historical management, dismissed search are logged in as eliminated queries. And for example, if it's near Father's Day and my father play basketball, I asked the system, his knee may panic sometime, and I need basketball shoes that should focus on cushion, and which basketball shoes should I get? And then the system will offer you some choices. And finally, in our system, the hybrid system notably reduces the first token latency by about 70% and cuts the LIPR from 2 to 1 compared to our existing RecSys-style baselines. And also, a rigorous online A/B testing between Hybrid-MACRS and the baseline CRS is conducted to validate its effectiveness. These two systems share the same procedure as the priority foundation, LLM, GPU, search engine, backend server, and front-end service, etc. The results show that the user option acceptance rate increases significantly by 8.2%, and the GMV per user increases significantly by 1.7% in a 7 days A/B testing. And thank you for your time. And if you have any further questions, please feel free to contact this email. And if you are interested in this product, please search Chinese word Jinghe in JD app. And thanks again, and sorry for these technical problems.
Okay, thank you so much. We have questions from the audience? Okay, no. So I have a question. And did you try your approach also in an e-commerce standard, we can say, e-commerce scenario? And there are some limitations in your model if you apply it to something different and is able to generalize somehow.
Sorry.
Yeah. And it seems your system, okay, is for e-commerce mostly, right?
Yeah.
Okay. And you think your approach can generalize to other scenarios that are not your, the one of your company, the one of your, you can say, e-commerce? And do you think there is possibility to adapt it somehow?
Yeah, of course. Like in other apps, like TikTok or whatsoever, when you search a query, and we can also adopt this kind of LLM-based search engine to provide users with satisfactory results.
Okay. Yes, thank you.
Thank you again.
Okay, so let's move. Thanks again.